Crude oil, fuel and carbon compound review sheet. Use this to start your revision as a helpful hint to your revision if you've missed a lesson for topics that you may not understand. So the first part we're going to look at is what is crude oil. So crude oil is a large mixture of hydrocarbons varying in chain length. How is crude oil formed? Dead marine plants and animals fall to the bottom of the ocean. They're applied to intense heat and pressure, and this takes millions of years. How do we separate crude oil? Fractional distillation, and that is based on carbon chain length. So you will have seen in class fractional distillation columns. The ones with the shorter carbon chain lengths will come out at the top, and the ones that have got longer, so the ones that have got longer will come out at the bottom. It is all based on boiling points, okay? So they're both hydrocarbons, but depending on what chain length they have, depending on where they come out in the fractional distillation column. The oil industry, which is what we then use from the fractional distillation, because that helps us separate it into oils, it causes a large controversy across the world. So there's a couple of things that you need to have an awareness of. The economic problems that come with the oil industry, largely that the big five control the price. So it's very hard for smaller companies that to get in, because the big five, which are stuff like British Gas, Swalec, control the price. Economically, that means that if the price is too high, people on lower income struggle to be able to pay for their gas and electricity. Social problems that come with oil. Wars have been fought over oil. It can lead to poverty, not being able to pay your gas and electrical bills. Political wars, again, countries that have a large source of oil often invaded or use that as their political bargaining tool. And then the largest one that comes with the oil industry is burning it. It releases CO2, which contributes to global warming. The fire triangle then is something you need to have an awareness of. The fire triangle contains three things: fuel, heat and oxygen, all put together in a triangle. How can we prevent fires from occurring? Water removes the heat. A fire break removes the fuel, and then a fire blanket removes oxygen. When we produce certain things in the fractional distillation column, we can then crack them to produce things like ethene. Ethene is a alkene, and some of the things that you can then do to ethene that makes them more useful. You can add hydrogen to them. It's called the hydration of ethene. It requires quite a high temperature, pressure and access to a steam catalyst. And as you add the hydrogen over the double bond, because it's quite reactive, you end up with an alkane. Another thing you can do, which is called the bromination of ethene, it happens at room temperature, so the conditions are much less volatile. Again, add it over the double bond because it's quite reactive, and you end up with this structure here. Moving on then to the general formula of alkanes and alkenes. So alkanes are CnH2n plus 2. Like I said, if you can learn that, you'll be able to draw and name any alkanes, because you know exactly what their formula is. Alkenes, then you remove the plus 2 because they've got the double bond, and it's CnH2n. Just a couple of drawings. So ethene looks like that with the double bond, and then ethane looks like that. How do you test for alkanes and alkenes? Bromine water. Alkenes, because they've got the reactive double bond, will turn from orange to colourless. How are these alkanes and alkenes made? They are made in the process of cracking. Cracking is when you take the long chain hydrocarbons from fractional distillation, so they're made in fractional distillation. They're not as useful as the short chain ones, so you split the long chain hydrocarbons into shorter useful hydrocarbons. You make one alkane and one alkene. Them alkenes, so the ones with the double bond, are then subject to addition polymerization, which is joining the short chain monomers into long chain polymers, which we use to make plastics. Plastics then have loads of uses to us. These are just some examples of plastics, the examples that you need to know. So polyethylene, polypropylene, PVC and PTFE. Some properties of them. So polyethylene is hard, rigid but high impact. polypropylene, low density, heat resistant, PVC, weather resistant, PTFE, slippery, chemically unreactive, and then some uses. Some modern day uses, you might be asked why we now use PVC compared to like wooden window frames. That's because they're weather resistant. Why do we use polyethylene for plastic bags as opposed to things like paper? Again, it's harder, rigid, can be exposed to high impacts. You might be asked that question. What are the problems with disposing of plastics? It takes hundreds of years for them to biodegrade, okay? And when you burn them, they release CO2. So another thing you might want to write here, burning them burning them releases CO2, which again contributes to the environmental problems. Another thing is they end up in oceans. We've all seen the pictures of turtles with their plastic bags stuck around them. Now, something you could maybe use instead of crude oil and all the oils as a fuel is hydrogen. Hydrogen can be used as a fuel because it doesn't produce any CO2 and the only byproduct is water. So you essentially add, so what you do is you add, so it's like H2 plus O2 goes to H2O plus energy. So you add hydrogen to oxygen and that produces the energy you need to power your car or your house, but it also produces water as a byproduct. So there's no carbon dioxide being produced. The big problem with this is that hydrogen is quite volatile, so it's very hard to store. So if we wanted to transport it to a power station, we've got to think about that long term. That can work out quite expensive. So it's very hard to store. It's very volatile. The main way that we currently in this country produce energy from our fuel is to use combustion of a hydrocarbon. So you put the fuel, such as petrol, put it with oxygen, you produce energy, water again as a byproduct, but you also produce carbon dioxide. Okay, that carbon dioxide can lead to global warming. Incomplete combustion produces carbon monoxide and not carbon dioxide. This equation then here is actually the incomplete combustion of fuel. So it's not a combustion of hydrogen. If you're looking for the combustion of hydrogen, I have put it by there. Okay, to balance that out, if you need to, just put a 2 by there and a 2 by there. So that equation there is the equation for the incomplete combustion. And as you can see, carbon monoxide is produced compared to the carbon dioxide in that equation.